Hello and welcome to this review of special analytics to elucidate the incubation period and drivers of visceral leishmaniasis. If you're new here, my name is Collins. I am a researcher from Kenya and I review machine learning papers that are used to solve problems that we have in our continent. Right then, let's get right into it. Now, VL is a severe and neglected tropical disease, and of course, this makes it a public health concern. And Kenya specifically has experienced multiple outbreaks of the disease since 2017. The researchers listed in this paper implemented statistical modeling and machine learning modeling. Some of the models they implemented include spatial logistic regression, Bayesian modeling, random forest, support vector machine, ADA boost, logistic regression, and extra trees. And of course, remember the goal of this research was to estimate the incubation period, right? Now, VL is endemic in 80 countries, and although it occurs in many countries, 66% of cases are experienced in Eastern Africa. And so this just highlights how big of a deal this research would be for Kenya in case it comes up with some interesting ideas, because this could be used by the Ministry of Health and other research institutions to build policies to counter this issue. And of the 47 counties in Kenya, 11 are experience VL, right? And the researchers found that these counties are disproportionately poor, marginalized, semi-arid, and underserved. So these would typically be somewhere along the northern corridor of Kenya. And one thing that has been problematic about this disease is that its control has been mainly reactionary. And like I mentioned, I'm going to mention this multiple times in this review. If this paper comes up with certain interesting ideas, then this can be used to make the control proactionary or proactive instead of reactionary. And of course, we've already mentioned that the optimal incubation period is not known. Right. For non-Kenyans around, the study was done in Turkana County, which is, you might recognize Turkana from the fact that it is named the cradle of mankind, and it is the second largest of the 47 counties in Kenya. And it has a hot and dry climate, and this is important because of what the researchers found. And it has a mean annual temperature of about 30.5 degrees Celsius. The annual rainfall is also low. It's a hot and dry climate, right? The researchers used data consisting of patient, weather, environment, and demographic variables. They collected patient data from 12 public hospitals in Turkana County between 2019 and 2020. And the data they had contained 1,600 records. I mean, there's not a lot of data, but if you're dealing with such a problem that is causing issues to the whole country, I guess you could work with whatever you have. And so, of the 1,600 records, there were 770 positive cases and 900 negative cases. And the patient's data contained age, sex of the patient, the village, coordinates from which the patient came, the hospital name where the patient was treated, the date the patient was seen in the hospital by the physician, and the kind of VL test that was done. And the researchers also obtained weather data from Open Meteor and NVDate. Those are cited in the reference section below. You can always check it out. And they also obtained environmental data, water bodies, land use, and land cover, and soil type variables as well from NASA, interestingly. And they obtained demographic data from the KNBS, the Kenya National Bureau of Statistics. Right. Not a lot of data processing was necessary just from reading this paper. Most of it was just imputation of mean age. I would imagine that the researchers took great care to digitize the data that they obtained from the public hospitals, and this would be the case for this would be the reason for needing only minimal data preprocessing. And an extra engineering step that they did was to compute the Euclidean distance between the patient village and the hospital they visited, and the location where the patient lives, and the water bodies. Right. They also did Z-score scaling, and that can be that is also one of the preprocessing steps, I would say, that they did. And like was advertised, they implemented multiple machine learning models for this. Now, it is interesting that from the features seen, the features you can see on your screen currently, you do not see the incubation period as one of the variables. But one interesting or one clever hack that the researchers did was to predict whether the person had VL or not. That is the test result, whether positive or negative. And then they lagged one month before that date of the date of that diagnosis, to check what were the prevailing weather conditions 2 months before that, 3 months, and so on and so on. And they actually mentioned that they lagged up to 8 months in the paper. I just forgot to highlight it, but it is explicitly mentioned that they lagged to 8 month periods. And back to the machine learning modeling techniques that they implemented. They implemented the random forest classifier, which is a forest or a combination of decision trees, to make sure that they work perfectly. And of course, there's a bugging technique and a bugging ensemble technique. And they also implemented support vector machine, which attempts to define the hyperplane, which clearly, or which as best as possible, separates the different classes that exist in the data. And apart from that, they also implemented logistic regression, which implements a sigmoid function to transform the probability of being in a given class into a class label, either 0 or 1. And of course, here they only needed binomial logistic regression because there were 2 classes. And extra trees is also an extension of decision trees. And so, yeah, some of the statistical modeling, before the statistical modeling, they did a spatial autocorrelation test, and this is used to check whether occurrence of a certain phenomenon or a feature is related or correlated with the locality or geolocation of where the observations were taken. And the specific method or statistic they used was the global Moran's one. And they also implemented spatial logistic regression, which is logistic regression for where, in case geolocation is needed or is present, and Bayesian spatial modeling. And for evaluation, the researchers used accuracy, precision, recall, F1, and area AUC, area under the curve, of the receiver operating characteristic curve. And for such a prediction, I would typically lean towards using recall, because we want to ensure that we classify every single person who is positive. Well, let's go. Accuracy just highlights the number of times the model was right, and the precision highlights the number of times that the positive predictions were actually true. And recall highlights the number of times that the model got positive predictions, and the F1 score is just the harmonic mean between precision and recall. And area AUC is this is used to ensure that there is a balance between the recall and the false positive rate, because assume you classify all people as positive, it means that all people who are actually positive are classified, but at the expense of what? At the expense of very many false positives. And so that is what the AUC attempts to optimize. Right. And the researchers also generated a risk map, which they deployed at. I'll show you the link of the deployment later on, but the probabilistic outputs were associated with the geolocation of the record, and this provided a future assessment of a possible VL risk across the Turkana region. And so they implemented this as a tool that users can use, or policymakers can use to see the things coming, sort of like an early warning system. Right then, these are the results from the models that were mentioned above, and the statistical models are listed first, and you can see that their AUCs are actually not so bad, and their best lag, this best lag, I would imagine this best lag predicts the incubation period of VL, and this is just the accuracy of the model, precision, recall, and 30% recall. It means that Bayesian Special only classified 30% of truly positive people as actually positive, and the same for recall, and the same for spatial logistic regression. I mean, the recall was 57%. And the researchers specifically focused on AUC because of the benefits we have already mentioned, and they found that AdaBoost had the highest AUC performance score, which is at 71.2%, which is not bad and not overfitting, I would say, because anything above 90-95%, those I would say would be moving towards the region of overfitting. But this is realistic out in the wild. And the precision score and the recall score is not actually that much worse than the best recall score, which was observed from extra T's, which is 67.4. And given that AdaBoost is consistently among the top, means that the researchers were actually justified in picking it, or in labeling it as the best performing model. And right then, from their sharp analysis, they found that the most critical the most critical features in predicting whether somebody is positive or negative. Somebody will test positive or negative for VL. The first one is age, distance to healthcare, the mean humidity, the greenness. These are, I mean, you can just read for yourself some of the features that are listed here. And starting from the bottom up, you see that forest height and soil type are not very important according to their findings. And this actually goes against or contradicts what the domain expert thought, and they've highlighted this here because they found that soil type and population density were ranked as less important, and this contradicts the understanding of domain expert, and this can be further investigated. And further studies can also consider the integration of socioeconomic variables to predict this. Yeah, I mean, at the end of the day, given the amount of data they had, I mean, they had about 1,600 entries or rows, and the fact that they could posit that these VL disease takes about 3 months to incubate between the time the human is infected until the time that the person tests positive, means that this is a step in the right direction. And they've also given this map, and you can see the link here to access it. They've also given this map that users can use to predict future occurrences of the VL disease. And so this will hopefully make control and management of the disease a proactive thing instead of being something that is reacted to once the cases have already occurred en masse. And in conclusion, understanding the major determinants, the incubation period, and the areas of high and low risk can be valuable to stakeholders in effective disease prevention and control, just like we've already established. And of course, they found AdaBoost to be the best performing model, like we've already mentioned as well. And this will be helpful to the Kenyan Ministry of Health and for other research institutions such as ICIPE and KEMRI to build policies that can then be used to manage and control this disease. Thank you.